Okay, so now we're going to take a look at page 3. So we now know what solubility is as far as making a solution and what the solute and the solvent are. So a solution has a solute dissolved in a solvent. So what impacts this solubility? How much of the solute can dissolve in the solvent? So first of all, solubility is how much solute dissolves in a solvent. Okay. And we also pay attention to what temperature, because we'll learn later that temperature can impact how soluble something is. So soluble, if something is said to be soluble, then it will dissolve. And if something is insoluble, then it won't dissolve. All right, so what factors? So the first factor we're going to talk about is the nature of the solute and the solvent. Okay, so the big key that I want you to make a note of when we're talking about the nature of the solute and solvent is whether or not the solvent is polar or nonpolar, and whether or not the solute is ionic, polar, or nonpolar. Okay? And this will kind of be like a crossword, like whether or not they come into play. The big key around solutes and solvents and how well they dissolve each other is this key phrase: likes, dissolve, likes. Okay? All right, so let's think about a polar solvent. So we know that if something is polar, a molecule is polar, it has a positive end and it has a negative end. Whereas if I have nonpolar, I don't have a positive or a negative end. Okay? So an example of a polar solvent, we've talked about water is polar. That's our universal solvent. A lot of things dissolve in water. Water is polar. Its shape, we have oxygen, and then we have our hydrogen like this. Okay, so water is bent, water is polar. So if I go by the likes, dissolve, likes, polar solvent will dissolve a polar solute. So if I have something else that's polar, let's say HF, this is going to be a polar molecule, so I'm going to have a little bit of a negative end and a little bit of a positive end. That's going to dissolve in our polar solvent. So this will be yes. And the reason why is the positive and negative ends are attracted. To each other. So the positive end of the HF will be attracted to the negative end of the water. And the negative end of the water will be attracted to the positive end of this, kind of like how magnets would line up. Okay? On the contrary, polar molecules will not dissolve in nonpolar solvents. Okay? Okay? So, polar and polar, likes, dissolve, likes. So then on that same respect, let's look at nonpolar. If I have a nonpolar solvent and nonpolar solute. So a nonpolar solute would be something like a fat or a grease. Okay? It doesn't have positive and negative ends. So it's not going to dissolve in polar. So I want you to think about if you had fat or grease or butter, I'm not going to wash that off with water. It doesn't work, right? So you can't wash fat off with just water. Okay, so that's a perfect life example. On the other hand, though, nonpolar will dissolve in nonpolar. Okay? So they have weaker bonds. So they will mix. Okay, and they kind of just break apart, mix together. Okay, so these are things like soaps. Okay, so that's why you have to add a soap to be able to get things to dissolve. All right, so then we're left with ionic. So if you had to guess, is ionic more like a polar or more like a nonpolar? Well, remember, if we have something ionic like sodium chloride, it's going to completely break apart into a positive and negative ion. So it's most like a polar. So sodium chloride will also dissolve in polar because of the idea of the positive and negative ends being attracted. And it will not dissolve in nonpolar. Okay, so we have the whole idea, likes dissolve likes, which basically says that polar will dissolve in polar, nonpolar will only dissolve in nonpolar, and then ionic will dissolve in polar because it's most like a polar one with the positive and negative ends. Okay, so the big key here is this one right here. We can't wash grease and stuff off our hands by just rinsing in water. And that's because water is polar and greases and fats are non-polar. Okay, all right, so you guys are going to go ahead and go to the front and you're going to get this polarity practice. So it should be a front and back. And if not, I've attached pictures, but you're going to go through, you're going to answer, what does polar bonds mean? Is it equal or unequal? Non-polar, equal or unequal? Then you're going to look at these molecules and use the rules that we've talked about and determine whether it's polar or non-polar. Then you're going to answer a couple questions about when we're trying to mix, whether or not things will mix together based on being polar or non-polar. Then questions like this, 11 and 12, they're giving you ethane, they're giving you water, and they want to know, would ethane dissolve in water? So you have to see, water we know is polar. You need to determine if ethane is polar or non-polar. If ethane is polar, then yes, it will dissolve because likes dissolve likes. Same thing here. Now you've got ethanol. Water we know is polar. Look here, is it symmetrical? If not, then it's polar, and then it would dissolve. Okay, so that's the questions you're going to do there. Same thing for these up here. Should oil that's non-polar dissolve in hexane? So here's hexane. If oil is non-polar, determine what this is. If it's non-polar, then yes. If it's polar, then no. And then some short answer questions. Okay. All right, so good luck with all that. And if the papers, these handout for some reason isn't up in the front, then just go ahead and answer the questions on the back of your notebook. The back of your notebook is plain, and you can just number and answer the questions on the back there. Okay? All right, good luck, guys.